Thank you, Carol. Thank you, everyone, for coming. Hope you're enjoying the amazing cybersecurity conference. I couldn't actually participate in most of the other sessions, but I actually caught up on a couple of those this morning. I'll probably do a little bit later in the afternoon as well. So thank you again. By the way, that picture is just 3 years old, so it's like just doesn't have the glasses, I guess. All right. So I think we wanted to talk about a little bit around an enterprise framework for data protection. And coming from a customer and someone who has actually implemented this for a couple of enterprises, I think it was good for some of the participants in the conference to kind of get the other side of the story rather than Micro Folks telling you how good their product is, which is still good because otherwise I wouldn't have been using it. So just a show of hands, how many are actually responsible for data protection or crypto in their company? All right, just a couple, okay. And you never know, some of those who didn't raise your hands, you probably would be. Yeah, it's like, for me, I never thought I would be on the information security side. As Carol was mentioning, it started off with contact centers, got into cloud and CI/CD and of course through reorgs. I didn't really have a choice. People just put me in the stuff that they thought I'll be able to do. I think the only conscious and purposeful decision for me to take another role was information security. I'm glad I did that. All right, let's move on. A little bit about Worldpay. So Worldpay is the #1 merchant acquirer in the world, payment processor. A little bit of the history is it used to be Vantiv on the US side. That used to be one of the leading merchant acquirer payment processing company, did a lot of acquisitions until 2018 January. They acquired Worldpay, which was based out of UK. And Worldpay was already global at that time in terms of their expansion in the Europe, Asia Pac, Latin America, and then they were started to expand in US as well. So Vantiv essentially acquiring Worldpay gave them the global footprint there, and they retained the name Worldpay. The company which was acquired, that name actually got written because it resonated with their strategy from a global standpoint. And as you can see, we do 40 billion transactions a year. We process those. And obviously, when it comes to payment processing, PCI data, PAN, and from a merchant acquiring perspective, PII data, these are all in scope. So data protection is a very integral and a very strategic program, for Worldpay. Some information around different products that we have, and of course, you probably have followed the news about FIS acquiring Worldpay. So we're actually going to be a part of a much bigger organization. FIS is pretty big, 45,000 employees, whereas Worldpay is 8,000. So obviously like 6 times the size. So next time when I'm doing a presentation, we'll probably change this chart. So that's about Worldpay, and I've joined last August. Used to be with American Express, before that TCS, and then last August I moved to Cincinnati from Phoenix, Arizona. It was quite a change. Survived the -4 Fahrenheit in January, which was unimaginable, being in Phoenix, right? So, all right, reality. Whether you like it or not, that's the scenario. You will be breached. And I think one of the very interesting points that a very senior, experienced information security professional, I think it was one of the Microsoft Customer Advisory Board, he was actually brought in as a guest speaker. He mentioned that, and that stuck with me for a while. He said there are 2 types of companies. One who have been breached, and they know about it, and the other who don't know about it. And that's really, really true. I mean, in terms of the breaches that have happened, and we were talking about Equifax in the previous session with Reiner, Marriott. You can see when it got detected, it was found out that actually this exfiltration of data was happening for several years and several months. So they didn't know until it was detected. So typically, you are in a position that you just don't know what's going on. If it's insider threat or it's an external, hacker exfiltrating through your system, exploiting some of the vulnerabilities, and then boom, one fine day you're on the headlines that so many millions of information, private or personal information, have been exfiltrated. And the other part is possibly again, there are like repeat instances of that, because people just think that, oh, I've got a few of these things covered, so I may not be breached. But these are happening at a regular basis. Not a single day goes by that you don't actually hear about some of these stuff. Now, when we look at some of the traditional approaches of enterprises, and me being on that side and working with large organization or being part of large organization and the different application and platform teams, you come across these posture of what we are doing currently and how is it enough, or we are covered, right? So I think some of these are very typical because of the ease of implementation, and it doesn't really take a lot to implement. And sometimes they're basically checking the box. So we've got transparent encryption, encryption data at rest. So we are good, and the regulations basically tell us that, oh, you are encrypted or you have transparent encryption. So your data is encrypted, so you're good. So some of these are kind of like those traps, right? Transparent encryption is enough for us, like basically saying that I'm just trying to prevent someone to steal the disk and run away from the data center. And that's the level of protection that right now we are having. And most of these regulations and laws, they don't explicitly talk about that until you're exposed. And then when they investigate that, oh, what level of protection did you have? And then you find out, oh, that was not really good enough because you didn't really protect my data. You were just encrypting a database file, or might as well just do a database or a storage. TLS protects our data in transit, a very classic one. There's a lot of reliance on that. And we know, and me being part of application side, development side, platform side, there are challenges with, in terms of TLS implementation. And I'm not going to really talk about quantum computing or quantum attacks and asymmetric cryptography, at what point that would actually essentially be broken. But even then, whether it's going to get broken or not, a lot of times, TLS, we have challenges with that. We have vulnerabilities, they are turned off, from a performance standpoint. And then you have SSL offloads at multiple hops. So you're creating all those exposure at different points in the network. But this is something that a lot of companies essentially. Hello? Yeah. All right, good. So that's one of the other ones that, this is a classic one. Through mergers and acquisitions, I think this is getting a little bit more prevalent, where you acquire multiple companies and they have their own IT department, and they're possibly not having information security department, and they are the ones who are tasked to protect their data. Traditionally, information security organizations have been the ones to define the standards and the policies, being on the ivory tower and say, thou shall protect your data. Now it's up to the LOBs, lines of business, and their IT teams to ensure they're compliant. So what we're doing is basically telling them, all right, figure it out. I'm just writing the policy here, and you should be protecting your data. So now they're trying to figure out, how do I implement data protection that, one, doesn't impact my business functions, doesn't impact my performance SLAs, and yet comply to the standards and policies. Worst case, if I don't, I'll raise an exception, and that will be tracked, and I'll be asked to provide a compliance plan. I will visit 1 year later and tell them the same story, and I extend the exception, right? So that's a very typical model. And that's where we find a lot of these gaps where information security would say, we told them to do this, we have an exception, so we are good from our standpoint. And the application team is saying that, yeah, but we tried to implement this, we didn't have the solutions, we were not given any prescriptions, and we were not even told how to preserve the functions while we're encrypting data. Then obviously they resort to some of those lower level encryption, which is very less invasive. So they will just apply some transparent encryption lower level, check the box. Classic one. So we're migrating to the cloud. Everyone does it for the right reasons: scalability, agility, and all the other business and market advantages that they need to take. So there's no exception to that, and that's where the industry is moving. But the reliance is somehow on the cloud service provider that they will protect our data. That's a big bet. How many times we've seen on the papers around that there was a security misconfiguration on the storage, on the cloud side. I'm not going to name anyone. And then data got exfiltrated or breached or compromised. So this is a big bet that enterprises actually make to hold the cloud provider responsible to protecting their data, rather than they taking that under their control. And there are certain teams, lines of business within enterprises that try to do the right thing. They're probably doing some level of encryption at the application layer, and they've got OpenSSL, Bouncy Castle, Java cryptographic extension, like libraries, and generating the keys, AES 256. They're all compliant to the standard because the standard says AES 256. So I'm generating AES 256-bit keys, and I'm encrypting. And we're good. So that's where you leave it to the individual application teams to do some of the stuff. And from a security standpoint, the guys who are maintaining the standards and policies say, yep, they're compliant. And that's it. All right. I think this is a picture everyone remembers or have seen it. Superman movie. Lois Lane falls off the helicopter. And she's falling down, and suddenly, whoop, Superman comes in and rescues her and say, easy, miss, I've got you. And Lois Lane finds, okay, it's like no one holding this guy. So, hey, you got me. Who's got you? And I find an uncanny resemblance with this to our data protection, key management, encryption, and all these other stuff. Think about the classic scenario of like, okay, we are encrypting data. That's great. That's Lois Lane, and Superman is the encryption key, and they've got it protected. Okay, who's protecting the encryption key? Where did you store that? Oh, you have it on the database column or in a separate table. Okay, who is protecting that key? Oh, we have it password protected. So you got a key that was used that was probably using another master key to get protected, and the master key is stored somewhere else, and they say, okay, who's got access to the master key? Oh, we got password protected. So every hop, you have a Lois Lane looking for a Superman, right? So it's basically kind of a chain. So this is one of those classic examples, like, okay, you got the data, who's got the key? Okay, you got the key by a master key, who's got the master key? Or you got the master key by a password, so who's got the password? So it's a cycle, right? So and I actually recently wrote a blog about this as well. So, and I really like this. And then we got all the other risks, in terms of the OAP's top 10, SQL injection. It's kind of the number one, which allows you to basically exfiltrate data, authentication, session management, data exposure, broken access control. Security misconfiguration is another one, especially in the cloud space. We found quite a few references of security misconfiguration leading to data exposure, and using components with known vulnerabilities. So we remember Equifax, the same thing. Now, if you're in your retrospect, how did these breaches happen, and whether it was just the only thing that led to the breach? Maybe not. nobody really has gotten to the point of, you know, revealing exactly what went wrong with Equifax or Marriott. But as you kind of uncover some of these different areas, they say, of course, there was a vulnerability in the application that got exploited. But then, how was the data, protected? Did they leave the keys at the same place where the data was? How was the credential to the database from the application tier exposed? How did they even get to that, right? So there's several factors in terms of secrets management, key management, data desensitizing, and stuff like that. And you may argue that, okay, even if they had encrypted the data at the field level, if the keys were exposed, that wouldn't have really, made any difference because they could have decrypted it. Then you can talk about how did they even get to the database? Well, obviously if the password or the credentials to the database were exposed, then they would have gotten to it. So it's like multiple factors, right? I mean, so doing one thing is not really gonna make the cut. And I think that's the important part of it. So I'm gonna share a little bit about the Worldpay approach and the strategy that we have, and it's something that we're kind of working towards, and my team is implementing. So I think this diagram actually is very interesting, and you could flip this pyramid or triangle, other way around as well. You've probably seen some of the vendors may actually have a similar diagram with that. But what it really says is, at your top, you perform the application layer, data protection, encryption, tokenization, hashing, whatever. And then as you go down, you're applying more transparent encryption, at the different layers of the stack. And you can see that the security effectiveness actually increases as you go up the stack, but the ease of implementation increases. So technically you would see the reliance is more down the stack, that, okay, I can just quickly turn on transparent encryption, and that's not going to create any issues with my applications. No code changes required. Data is going to transparently come out. We may actually do some performance testing to see if there aren't any delays or missed SLAs. But typically, doing application layer data protection is a little bit more invasive, and that's why people try to avoid it. But the layer of, or the effectiveness of the data protection or the security that you're putting in is significantly increased as you go up, where you start desensitizing data. And as you go down the stack, there are so many things that you got to put in, to compensate for not desensitizing data. You got to make sure your privileged controls, privileged access controls are in place. You got transparent encryption with a key management that's solid. You don't really expose the keys and have the DBAs that have access to the tables as well as to the keys. You got to have multi-factor authentication, vaulting of the passwords. You've got data masking and redaction. So if someone is actually making a query, a DBA, a privileged user, and doing a SQL query that basically does a select star from so-and-so table where column name is span, like 1 million credit card numbers. So you want to make sure that those are redacted or masked so that those don't happen. Then you got database activity monitoring to be in place. So who is doing all that, right? And how do you basically, out of the million events that happens, it's kind of finding needle in a haystack. Your SIEM or your SOC is tasked, or insider threat is tasked to decipher one of those events from the other million events and make sure that the data is not getting exfiltrated, because the insider threat is pretty huge. And then network encryption, again, TLS. So think about the kind of controls that you have to put in place in order to compensate for the lack of data protection at the application layer. So either way, if you want to provide the security effective. Hello? Okay. You gotta have a lot of the dominoes that needs to fall in place. So one of the things that I had to do coming in to Worldpay is to basically have an enterprise global standard approach. So Worldpay being obviously a conglomerate of multiple companies. Is it working? All right. And obviously through serial acquisition, we have had multiple different LOBs, multiple different companies and their IT and IS processes. And from a data protection and crypto standpoint, my strategy was to kind of bring it all together and have one enterprise solution, one enterprise framework. So that's one of the approaches that typically, if you are part of such organization, one of the things that you definitely want to take a look at is how do we have a global standard and an enterprise, truly global framework that you can tie all the different lines of business into, from a data protection standpoint. Because not only is just from an operational expense or a security and all these stuff, but there are a lot of islands that you will create not being able to tie multiple entities together, particularly for data sharing use cases. Shift up the stack, that's obviously one of the biggest strategy that have been kind of preaching, and then having the data security model being more data centric, applying the protection at the field level, at the individual data point level, so the data gets desensitized and devalued. I think one of the myths of information security organization or any enterprises is that data protection team or crypto team is going to prevent breaches. I think that's a myth as far as I'm concerned. Just my opinion. People can disagree with that. I don't think my job is to prevent a breach. My job is to make sure the impact of the breach is either eliminated or alleviated. Because I don't think from a crypto or data protection standpoint, you will be able to prevent data getting exfiltrated because there are so many areas where things actually could go wrong. But when it comes to the last line of defense, that even if data got breached or when it gets breached, you just basically make it less impactful for your company. And even from some of the regulations like GDPR, it says when you have that right to notification, that if you get breached and at the point when you detect the breach, you have 72 hours to notify your customers. But if your data was desensitized through encryption or tokenization, you're not required to do that. So that's one of the things that also from a privacy standpoint, they're making it clear that, okay, we understand you will get breached, and you make sure you notify your customers that you have been breached. But if your data was desensitized or devalued, then you don't need to. So I think that's where my focus has been, is to make sure that when we get breached, because that's what saying I'm not the one who's going to prevent that. When we get breached, what I have done to the data so that after data gets exfiltrated, the impact has been minimized. So I think that's one of the things that we've been targeting for. This is a great value proposition for the application teams, because it's a very difficult conversation to have with developers or application or platform teams that, oh, you gotta now make code changes and encrypt data at the application layer. And there's initially this pushback on that, oh, that's a lot of work, who's gonna fund this and that? How would my performance get impacted, because encryption will add overhead? How would my business processes work? How would I search, sort, report, all these things that come in? And you have answers to all of those. But as soon as you talk about that, I'm going to take away key management from you, suddenly then you've struck a chord with them, and they, oh yeah, we like that. Because they don't want to do that. It's like the whole Lois Lane Superman example. They're encrypting data, and then they're managing the keys, and then they're essentially protecting the key with something else, and then there's a password, and then compliance comes in, then no, you can't have that here, or you got to have separation of duties, or you can't store the password here, or not in a properties file. you got to protect it, and there's a lot of stuff, right? So in order to be compliant, they're struggling with key management. And if you can abstract that key management from them, never give them the ability to actually hold a physical key, and they actually never know what that key is, they're excited, because that's what they're not really willing to do that. They want to do the right thing, they want to protect the data, but if you ease that whole struggle they have with key management, they love it. Same thing with secrets management. Very typical implementation of application code is storing passwords, API secrets in a properties file, sometimes even hard-coded. And then you get into the issue of rotation of those secrets. Then they have a update moment, which essentially means they got to change that code or properties file with the new secret or the new password, and then redeploy the code and take an outage. So all these things are a big struggle for them. So if you can abstract the secrets management, even though it doesn't really fall under me in the data protection thing, it's more kind of on the privileged access management side. But that's something we have kind of incorporated into the whole strategy, is give them a capability where the password and the secrets are vaulted, and API that at runtime will fetch the current password. And you can rotate the password and the secrets as many times you want. There is no requirement for any update or redeployment of their code. This is one of the biggest bets. Typically, like, people start off with figuring out the on-prem implementation, but when it comes to cloud, they get a little bit clueless. So one of the strategies is essentially, if you have applications deployed on on-prem servers or private cloud, or you are on AWS or Azure or GCP, it doesn't really matter. From our strategy standpoint, we're going to basically take the entire encryption stack up to the cloud, provide the encryption clients that get embedded into the images, and as soon as containers spun up, they have the client. The key servers that those clients need to talk to, they're local. Sometimes we are hosting it on AWS, sometimes it's on-prem, as long as the connectivity is there. And through key caching, you are reducing the dependency on the network and also allowing them for high performance levels. When it comes to SaaS, that becomes an interesting space, because the application teams are not really coding there. There's not many custom code, and they're just leveraging, a service provider's service, and just the data is there. So where we can take our encryption, we are taking our keys there. AWS KMS, Salesforce Shield, Azure Key Vault, and these are all these different cloud service provider platforms that allow customers to bring their keys. And those bring your own key models are varying. Some cases you are actually pushing the data encryption keys, which they are protecting at their vault. And then in some cases, you are pushing a key encryption key, where their data encryption keys, which are used to protect the data, is being protected by your key. And in some cases, if it's in another level as well, in higher level. So sometimes, you kind of question about the effectiveness of really how much I'm buying in order to push our keys there. But at one point, you are the one who are holding that master key or actual data encryption key, so they don't use that. So there's the strategy around bring your own key for the SaaS. Well, you can't protect what you don't know exists. So obviously, scanning, discovering of data is a kind of a continuous activity that you have to do. And as you periodically scan, you will find new instances of data across cloud environments, and people have just put in there without even going through the right process. Very, very prevalent in any large company. Mandating crown jewels for application level. And I think this is a tricky one, right? Because obviously, one is, how do you define your crown jewels? And then how do you address preservation of your business functionalities while your crown jewels are protected? Because typically those are the ones people are reporting on, people are searching, all their SQL queries are based out of. So I think it's kind of more art than science, that defining your crown jewels and making sure you mandate only specific fields for encryption, rather than telling them to encrypt everything at the application layer. Because obviously we got to balance performance, business functions with security as well. And sometimes people go overboard with the word PII, and they think, oh, zip code is a PII, so I should be protecting that because my standard says you should be protecting PII. And then people just forget about the association of that. Okay, does this particular field in isolation sensitive enough? Or when it actually gets tied to multiple other fields, then you actually get to information that you can identify a person uniquely. And I think that's some of the things that needs to be worked on in terms of, okay, what I'm really protecting at the application layer, and leave the rest as a discretionary. And some teams will actually go and encrypt a lot of the other stuff, as long as it doesn't impact their performance as well as some of the business functions. This is another aspect that you'll find that everyone thinks that, okay, data is being passed around to multiple applications and I have to decrypt data while it comes to me. But when you look at all the business processes, you find that most of the applications are not really interested in the whole data. They're kind of looking at certain elements of the whole data. Like very classic example would be the bin range of the credit card number. And all they care is about the bin range. And then if you leave that bin range in the clear through partial encryption, then those applications don't even need to decrypt data because they are able to view the bin range and then make their routing decision stuff. Another example would be last four of social. In a lot of the cases like customer service rep or applications, they're looking at the last four to probably authenticate or validate the caller. And their application doesn't need to decrypt the social as long as the last four is exposed. So I think defining the encryption formats is very crucial when, one, you are not integrating or having all of these applications as data pass on to your encryption stack, and you're also reducing the overhead of multiple decryption as data passes. Creating obviously protected ciphertext or tokens. So that actually helps a lot in terms of your scans, audit, and people are looking at, and with downsides of format preserving encryption is that a credit card number can exactly look like a credit card number, right? If you're just doing typical format preserving encryption. But when you make it obviously protected, then obviously you have alphabets and stuff like that in your ciphertext. So someone can look at it and say, oh, no, I understand this has been obfuscated. A lot of cases, if you just leave it in the clear, sometimes you don't know. Are you looking at the real credit card number or an obfuscated one? And some people push back in terms of, oh, my database column, the schema has been defined as integer, and I cannot accept alphabets. I'm like, why would you define data field column as integer if there are no computational requirements for it, right? I mean, are you adding credit card numbers? Are you adding social security numbers? So I think those are some of the discussions that you get into. Obviously, people don't like to change because someone else defined it and they thought that was going to work. So I think those are some of the issues that come up, but not something that we won't be able to solve. Data sharing, protect your access their model globally. I think this is a big one. Our strategy is essentially having a single global virtual system distributed geographically, UK, US, wherever, AWS on-prem. So you allow data to stay persistently encrypted when multiple applications across the globe are sharing data with each other and give them the ability to consume that data. Otherwise, when you have one system with a siloed encryption solution encrypting and the other one trying to decrypt it, you will have to basically decrypt that data before you send it out, right? And now you're creating an exposure, and then you're relying on TLS and all these other stuff. And I think one of the things is basically streamline the adoption, for your developers. So give them the ammunition, give them all the tools that they will be able to consume your solution. Just telling them, here's the client, figure it out, encrypt data, that's not going to work. So you got to give them with wrappers, different tools, to validate. Some people say, oh, I have a production support guy that needs to see the data to troubleshoot during an incident. And if you have encrypted data, how am I going to really troubleshoot? Because there's a specific field that is the issue. And if you have encrypted that field, obviously you need to give them the ability to decrypt at the point when you have an incident. So a little bit about secured data. How many in the room on the customer side are actually using voltage secure data? Just by the show of hands. All right. So I think you guys are obviously familiar with the product. So format preserving, partial, obvious protection, whether it's encryption, tokenization, hashing, those are obviously different features of the product, which is great, and in terms of how you apply it and what the cases are. Structured, unstructured data protection. This is probably one of my big differentiators as far as choice of the product is concerned, because I think format preserving encryption, even Voltage kind of pioneered it. It was like one of those things that was basically the next best thing after sliced bread. But I think that now a lot of vendors have done that. So it's, even though it's a very powerful technology, it's no longer a novel or a niche. But where I see some of the high value propositions are the reduced attack surface. So Voltage doesn't really store keys, right? I mean, it's not really a traditional key management system. So I think the way it does derive the keys at runtime, and then even if your Voltage was compromised, the key servers, really you don't have anything to actually get out of it. So that's one of the things that helps in a lot of cases where key rotation requirements, and then obviously not having to store the keys, which means all the other processes to protect those keys and the system and hardening the system essentially is reduced. Keys not transferred or exchanged between apps. I mean, that's one of the things that I like it very much. Sorry, was there a question? Oh, sorry. That when one application encrypts data and you send the ciphertext to keep it persistently encrypted, you don't have to send the keys along with it, right? Which is kind of more of the traditional model that now you get into key exchange mechanism. So how do I protect the key while I'm sending the key? So on the other side, they can independently derive the key as long as they have access to the key server and the credentials to derive the key. So that's actually a great trait of the solution, that we don't have to now create an asymmetric cryptography model to protect the symmetric key that I have to share. So there's a lot of flexibility there. Embedded key management, that's the abstraction of the key management act. So you never give the developer the key in this model. What they have is an identity, which is basically a pointer to the key. And that identity could be in a form of an email address or any type of string that you define. And the key management is taken care of by the client. Or better, when you're doing a REST API call, that's actually inside the appliance. The key never leaves the appliance. So that's one of the advantages of the embedded key management. A lot of people probably have heard about this notion of envelope encryption. You'll see AWS KMS actually does that, where you encrypt the data and you store the key and then encrypt the key and then essentially concatenate the encrypted data and the encrypted key together, and you store that in the database. Now when it comes the time of decryption, you basically go and take the encrypted key, send it to the AWS KMS, decrypt that key, because that master key which you encrypted that key is in the HSM. Now you have the clear key sent. Now you use that clear key to decrypt the data. So there's a lot of back and forth, and then you're obviously storing more data. With the embedded key metadata that we use in Voltage's embedded format preserved encryption, the metadata information about which key was used to encrypt is already there. So it's very seamless when you're reading it. So you don't have to store the key information along with the ciphertext. And sometimes it's a great tool when you're rotating the keys. You don't really have to, for decryption purposes, have to know which key I have to use, because the ciphertext has that intel and the client can automatically figure out which key was actually used there. Obviously, it's multi-platform. There's nothing that we're excluding. Wherever your data application is, whichever platform it runs, Voltage has support for pretty much most of them. Client-based, which is local encryption, which gives you the performance, at tens of microsecond level. The keys cached for a period of time, which is configurable. And then you also have the ability to just do REST encryption, where the key never leaves. It's in the appliance. You just send the data to get encrypted or tokenized, and vice versa. Tokenization, I think, the vaultless aspect is a great advantage, because traditional token systems, you have a database vault, and then you generate a random number as the token, map that to a PAN, and then you keep on adding to that table as your table grows. Then you have clusters of database that needs to sync, eventual consistency. You got to have logic to not issue the same token for 2 different PANs or multiple tokens for the same PAN. And your token vault access could land into any of the database clusters. So if the sync didn't happen, then obviously you're essentially using a duplicate token. So there's a lot of things and then when you're storing the PAN and the token, you got to make sure the PAN is encrypted, because then now you're essentially having an exposure at the token database table. Now, as soon as you encrypt, then you get into the mix of, I got to rotate my keys. So that means a bulk re-tokenization has to happen, right? Or rather, a bulk re-encryption of all the PANs. So there's a lot of issues with the vault-based solution, but that has been the traditional model. Vaultless tokenization actually alleviates that, and it never stores any, PAN. That's the great thing. You send data, and it'll give you a token back. It doesn't have anything inside the appliance. Bulk protection utilities and UDFs. So these are some of the things that the Voltage Secure Data capabilities provide. You need to do a bulk operation of clear data to encrypted data, or clear data to token data, or need to do a rekeying exercise. And then you got UDFs for SQL Server, Oracle, Vertigo, and all the other stuff. All right, so from a recap and recommendation perspective, I think some of the things from a data protection standpoint is discover your data and drive some of the minimization, because there's a lot of the issues that comes with that, because the same data has been stored in multiple places. So I think it's very important to kind of take a look at that, even though that's not going to be probably part of a data protection or crypto program, but from a data governance perspective, data architecture, how do we drive minimization? So we keep the data at as much as a lesser number of places, but rest of the applications are actually working off of a token or a ciphertext, because the more places you have the data, the more places you'll have to protect it. So your remediation surface gets larger. So minimizing that actually helps in the program. Understanding the business applications, upstream, downstream applications, dependencies, viewing requirements, reporting requirements. So these are areas where before you start protecting data, you need to know that who is getting impacted. If data goes into a database encrypted, who are the other applications that are consuming that data? So, and if they can't read the data, what's the impact? And whether they should have the ability to decrypt it. So these are some that needs to be done. Eliminate point solution and take an enterprise approach. So I think I talked a little bit about it. This not only optimizes your operational expenses, the number of people that are managing these point solutions, and yet not having the ability to transfer data between applications seamlessly. And sometimes you don't even have the control and how key management is done there, who has access to what. So moving from these individual point solutions to a much more centralized, global, and security managed solution is one of the recommendations. The data-centric data protection strategy. So don't rely on transparent encryption. Implement more data-centric security, where you're actually desensitizing some of the crown jewels at the application layer. Things like credit card number, social security number, bank account number, some of the health, PHI, some critical information in there. This is one of the big bets that I have in terms of creating a single virtual enterprise system, even though they are geographically distributed. So I have the same system that's running in AWS, in US, in on-prem data center, and Europe, AWS and Europe on-prem data center. So it's a single system. It's just geographically distributed because the local applications can consume it locally. So there's not a long trip to the key servers. But every single system works the same, because if you encrypt here or tokenize here in, let's say, Ashburn, Virginia AWS, that data can actually be decrypted if it's get transferred to AWS Frankfurt-based application. It's kind of giving them that virtual single system capability. Of course, take away key management, secrets management from the developers. And trust me, they don't want that either. They want to just create new business functionalities and drive more business values and take advantage of the market. The more you abstract some of these key management, secrets management capability and give them the tools to do the right thing to protect that data, the better their job can actually be. And then they will love it and they want to adopt it, because all these complexities essentially pushes them away to do the right thing. And I think that's the thing, empathize with the developers. You gotta wear a developer's hat. It's very easy for information security professionals to be in an ivory tower mode and say, thou shalt do this, without understanding how their application works, without understanding how they will consume your solutions. It's very hard to drive adoption and risk remediation. So I think it's very important for information security and data protection professionals to really wear the developer's hat, so you can empathize that the challenges they face and how you can remediate or alleviate some of those. So give them all the tools, the wrappers, the APIs, provide them the ability to do bulk encryption or tokenization, and sometimes how their during an incident, how their production support team will be able to decrypt data if they needed to, or how do they validate the credentials before they deploy their code. And last but not the least, adopt a zero trust policy. Do not be in a mode that, oh, my service provider, cloud service provider is going to protect my data. Just have a very zero trust that, I really don't trust, how data is being handled, so I got to take control over it. I think if we have that mindset, then it's just going to be much better, because then you are not saying, oh, I thought the cloud service provider was supposed to protect my data. That's in our contract. But at the end of the day, your data got breached, and you really didn't really do anything to do about it, other than just saying that it was the understanding or in the contract that they were supposed to. But the damage is done. All right, so I think that wraps up. I'll be open for any questions. Yes.
Referring to your list of traps, we're going to do our own open source encryption and all that other stuff. Are
Yes.
you aware of, and taking into account that you're going to get breached, are you aware of any organization that has taken that approach where they've gone and done all these things, they've gotten breached, and regulatory authority after that said, well, you used data at rest encryption, you used this, you used that, fine, we're not going to penalize you because you did well enough by the standard. Does that happen in reality, or is reality, if you do this, does the legal authorities say that's not sufficient?
No, yeah, I'm not aware of that, how someone actually tried to do the right thing. It's not really about whether you're using a voltage secure data simple API client or a Vormetric application encryption client or an open source library, right? Because at the end of the day, you're using some crypto library to encrypt. I think it's not about whether the auditors would say that, no, you did the right thing, but some of the things got misconfigured, or you didn't manage the other ones that essentially got that compromise to lead to, and either you're going to be penalized or not. I'm not aware of those instances. I'm just talking from the aspect that it's just encrypting data at the application layer is not going to make the cut. So at the end of the day, you have to make sure your key management, secrets management, they are also kind of managed. Because a lot of people think if I'm encrypting data, then I'm covered. Now, from an auditor's perspective, it all depends like who the auditor is. I mean, sometimes we get audited and then they don't know enough about crypto and they're just trying to go through a checklist of items. Was the data encrypted? Yes. Okay, good. Did you have an access control policy of who has access to the password? Yes, we vaulted. Okay, good. So I think those are some of the conversation gets in. So I'm not aware of that, whether in some cases, because most of all we see that when these breaches happen, data is not even getting encrypted at the application layer. It's very, very transparent because, yeah, so I'm sorry, I won't be able to give you an instance where how that conversation went and what was the decision from a penalization standpoint.
Yeah, I guess you'd rather avoid the conversation.
Exactly. You do not want to get into the conversation. All right.
So you talked about driving adoption from the application development teams
Correct.
and so forth. Any nuggets there? I mean, kind of stick and carrot approach, and how do you inspect to validate the adoption?
Yeah, that's a great question. I think it's getting easier, I would say. One is leadership, backing sponsorship is very key. If your CIO doesn't see this thing as a problem and doesn't have that alignment with your CISO, then obviously there's a problem. But more and more we're seeing that that's no longer the case. I mean, they're taking it very seriously. Funding, obtaining from the board to do data protection, I think that conversation is getting easier day by day. And I think in a bad way, these breaches have helped the cause. I think it's where it gets to the point that everyone understands that we need to do this, and they all agree. It gets to a point where two things come into play. One, who's going to fund this development work? How much effort, obviously, is going to be required. And then getting over that anxiety and the concerns they have that, okay, that's fine, I know I have to encrypt the data, but how all my other business processes is going to work. So I think then that's why I kind of talk about the empathize with the developers. So having that understanding and then giving them the prescriptions and providing them with the tools and telling them how to do it in a lot of cases just eases that conversation. That was actually this week in a conversation with one of the applications, and pretty much typical questions. I have this data that is, we run reports out of it. How is that going to work if I've encrypted it? So I think that's where I see where until unless people jump into, they don't know it. So the quicker we give them the ammunition and the tools and make it happen for them, and they can see that in action, you kind of get to that point where they're still worried about. But in principle, everybody understands and wants to do that. I think it's a matter of how easy for it is and how long they're going to actually take it. And of course, the funding question comes in like, okay, we got a size for it, and we need to understand how many hours of efforts. All right, I think we were right on time. Okay, well, thank you so much for listening.